Greetings sir, this is Kokila 19E043 from Triple department. I am very happy and eager to present my topic Precision Rectifier. This is the overview. I will tell about the introduction about the Precision Rectifier, how it differs from the regular rectifier, its application and limitation, at last summary. Before we take a look at the topic, let's plunge into the introduction. Direct current is necessary to power the radios, televisions, computers, battery chargers, mobile phone chargers, etc. In fact, most of our household appliances. Here, I depicted a picture about the different types of rectifiers employed in our home appliances. A rectifier is an electric device which converts the alternating current into the direct current by allowing a current to flow through it in one direction only. In this presentation, we will see about the precision rectifiers. Here is how the regular rectifier differs from the precision rectifier. A normal rectifier can rectify the signal after the 0.6 volt, whereas the precision rectifier can rectify the signal of order of the millivolt. Normal rectifier consists of the ordinary diode, whereas the precision rectifier consists of op-amp and diode. Normal rectifier uses the transformer at input side to step the voltage up and down, whereas the precision rectifier do not use transformers. Normal rectifier is less stable and have poor efficiency, whereas the precision rectifier is more stable and has good efficiency. Normal rectifier acts as a power supply for the radio, television and computer. The precision rectifier is useful for high precision signal processing. The next slide is about the precision rectifier. The images are depicted here. It is a non-linear application of the operational amplifier. In a normal rectifier circuit, the diode conducts only when the input is greater than the cut-in voltage of the diode, and that limits the use of these rectifier circuits for the small signal conditioning and processing. That is the example of AM demodulation. And in such application, precision rectifier circuit is used. The precision rectifier circuit is designed using the operational amplifier and diode. Wherever, due to the negative feedback in the circuit, the diode behaves like an ideal diode. Hence, this circuit is also known as super diode. The conditions. When the input voltage is negative, there is a negative voltage on the diode. So, it works like an open circuit and no current flows through the load. Hence, the output voltage is 0. When the input voltage is positive, it is amplified by the operational amplifier, which switches the diode on. Hence, current flows through the load, and because of the feedback, the output voltage is equal to the input voltage. The next slide is about the application of the precision rectifier. Some typical application of the precision rectifier are half wave rectifier, full wave rectifier, peak value detector, clipper and clamper. Half wave rectifier. Its diagram is depicted here. When the input voltage is greater than the 0 volt, the voltage at the inverting input becomes positive. Hence, it forces the output VOA to go to negative. This results in forward biasing the diode D1, and the op-amp output drops only by approximately 0.7 volt below the inverting input voltage. The diode D2 becomes the reverse biased. The output voltage V0 is 0, and when Vi is less than the 0 volt, the op-amp output VOA becomes positive, forward biasing the diode D2 and reverse biasing the diode D1. The circuit then acts like an inverting amplifier circuit with a non-linear diode in the forward path. The gain of the circuit is unity when RF equal to RI. Here I tried a simulation for the precision half wave rectifier using the op-amp. The precision half wave rectifier using operational amplifier. Let's see the components identified. a voltage source, 2 diodes, 3 1 kilo ohm resistors. Next, a 100 kilovolt per volt op-amp. I have done with the connection. Let's play the simulation. Let's see the input signal. Let's see the output signal. Let's see them together. For all these simulation, I have given minus 1 volt as minimum voltage and plus 1 volt as maximum voltage, frequency of 1 kilohertz and time as 1 millisecond. I have done this in every circuit simulation app. Here, the images described the simulation for the precision half-wave rectifier using op-amp. The next slide is about the full-wave rectifier. Using the precision half-wave rectifier and the adder circuit, it is possible to design the precision full-wave rectifier, and its picture is depicted. By referring this diagram, the first part is a half-wave rectifier circuit and the second part is an inverting amplifier. When Vi is greater than 0 volt, we assume that Rf equal to Ri equal to R and the output voltage VOA equal to Vi. The voltage V0 appears as a negative input to the summing op-amp circuit. Input Vi also appears as an input to the summing amplifier. Then the net output is V0 equal to Vi. When Vi is less than 0 volt, the output V0 of the first part of the rectifier circuit is 0. Thus, one input of the summing circuit has a value of 0. Vi is applied as an input to the summer circuit, that is V0 equal to minus Vi now. Since Vi is negative, V0 will be inverted and thus becomes positive. Here, I would like to add about the peak value detector. Peak value detector detects and holds the most positive value of the attained by the input signal prior to the time when the switch is closed. The next slide is about the limitations. When the input to the precision rectifier is negative, the operational amplifier operates in the open loop configuration and it goes into the saturation, which limits the maximum operating frequency. It can be overcome by the modified precision rectifier. The modified precision rectifier uses 2 diodes. In this, 2 diodes are used and the second diode prevents the op-amp from going into the saturation, which increases the frequency response of the op-amp. At last, summary. Here I am going to say about the precision rectifier circuit. That is, it is designed using the operational amplifier and the diode, where due to the negative feedback in the circuit, diode behaves like an ideal diode and its circuit performance. Here, when Vi is less than 0, Vout equal to 0 volt. Vi is greater than 0, then Vout equal to Vin. Next we have seen about the 2 main applications of the precision rectifier, that is half-wave rectifier and full-wave rectifier. The half-wave rectifier circuit performance. When the Vi is greater than 0 volt, V0 equal to 0 volt. Then VOA, the output voltage of the operational amplifier, is minus 0.7 volt. And when Vi is less than 0 volt, the output voltage V0 equal to Rf by Ri into V1. Then VOA, the output voltage of the operational amplifier equal to Rf by Ri into V1 plus 0.7 volt. Next is about the full wave rectifier's circuit performance. When Vi is less than 0 volt, then the output voltage V0 equal to Vi. And the Vi is greater than 0 volt, the output voltage V0 equal to Vi. And next we saw about the peak value detector and about the limitation of the precision rectifier, and it can be overcome by the modified precision rectifier. Thank you.